natural number solution. Y'all, I'm going to take the natural numbers just to be the non-negative integers, 0, 1, 2, 3, and so on. So we'll say x, the member of the natural numbers. And again, there is some people use the natural numbers as 0, 1, 2, 3, 4 ad infinitum, and others call them 1, 2, 3. But today, I'm talking about 0. So we're looking for positive integer solutions, including 0. Now this is a congruence, and so it has some similarities with just the real valued solution to the quadratic equation. And I wrote that down. This is no need to go through this. This is the negative b plus or minus b squared minus 4ac. So you can see this is 121 plus 8. So I just wrote that down without showing the work. That's straightforward enough. Now this truth right here, it's always bothered me a little bit, but you can go back and forth between equality and congruence very conveniently. Now, this is an obvious fact, but it's worth writing down because I know sometimes I get stuck right in the middle of one of these things. You know, for example, right here, since a is equal to b, we know that 13 divides a minus b, right? 13 divides a minus b, and any moduli would work here. So 13 divides a minus b because that's equal to 0, right? A minus b is equal to 0. All right, and everything divides 0 except 0, right? Okay. Now this simple fact, again, a minus b, if a is equal to b, then a minus b is 0, and 13 divides 0 is trivial, right? So this turns out to be a very handy thing. Now the whole aspect that I think that's important right here is just, if you can interpret the square root of 129 modulo 13, you're effectively done with the problem, okay? Let's take a look at how that would go. Now this just goes all the way back to just the definition of square roots, all the way back to the real numbers, right? Square root of 129 is equal to a. If you square both sides, you get this. Now notice right here that I went from equalities to congruence basically because of this. You can, and it's useful. Now notice that 129, I replaced 129 with 12. That's because 129 is congruent to 12. Right, and if you subtract 12 from 129, you get 113, right? That's because 13 divides 129 minus 12. What is that? 117. Okay, folks. And 9 times 13 is 117. So that's very nice. We scaled this thing down using properties of congruences. Is that right? 129 minus 12 is 117, and 9 times, yeah, that's correct, okay. And so we got this going on. So we got 12 is congruent to a squared mod 13. Now notice here that I quickly did the 5. What you really need to be doing right here, folks, is you can just check all the members of a reduced residue class. In other words, not reduced, but just a complete residue class. 0, 1, 2. Remember, in fact, you could have done this just at the beginning of the problem if you felt like it. But dot, all the way to 12, okay? And those are the possible remainders when you divide any number by 13, okay? You can have a remainder of 0 if it's a multiple of 13, or you can have any one of the remainders up to 12, which is 1 less than 13, right? So that's what I did. I just checked, and I got to 5. Okay, I got to 5. Notice that 12 is congruent to 5 because 5 squared is 25, and 25 minus 12 is 13, which is certainly a multiple of 13. Okay, so so we get that 5, and this is a big deal. We get the square root of 129 modulo 13 is actually just equal to 5 in modular arithmetic. Notice the square root of 129 is certainly an irrational number. But in modular arithmetic, the square root of 129 is incontrovertibly equal to 5. And so what we did right here is replace the square root of 129 with 5, and we get these two statements right here. You get these two values, minus 8 and minus 3. Now notice the original problem called for natural number solutions, non-negative solutions. And so what we can do, folks, right here, by the way, these are solutions which you could check. But we can actually just write down x equals 2 Now, these are the two solutions, sorry. But if you want the positive solutions, you can just add 13 to both of these because that'll shift each of them to the right 13. It'll still be a solution, okay? So in other words, that let's just write it directly underneath here. If you add 13 to this, you get, what, 5? And notice that 5 is congruent to minus 8, just by the way we've constructed this. 5 minus negative 8 is equal to 13, or minus 8 minus 5 is equal to negative 13. Now, if you add 13 to this, you get 10. Okay? So this is what the problem called for. 5 and 10 would be our solutions. Okay? I'll go ahead and circle it, but we will take the time to check this. Okay? So 5 and 10 are the solutions. And let's check here. So here's the original problem, right? So right here, for x equals 5, that would give you 25. Again, folks, I'm doing x equals 5 here. X equals 5 right up here would give you 25 plus 55. Minus 2. And that is equal to 78. Okay. Now notice that 78, whoops, always run out of room on this crazy thing. Okay, 78, whoops. Okay, so 78 is congruent to 0. And y'all, it's understood it's mod 13. Okay, so 78 is congruent to 0 because 6 times 13 is 78, right? Now let's check 10. If you check 10, let me give some more room because I ran out of room just there. If you check 10 right here, you will get 100. Again, y'all, I'm substituting 10 right here. Now also, if you substitute 10 here, you get 110. Minus 2. Okay, now this is what, 210, 208. That's equal to 208 is what I'm getting. And that better be congruent to 0. And I believe it is because it's 13 times 16, right? Note that 208 is 13 times 16 is the justification. See, it leaves no remainder. That means there's no remainder, and that's what congruence arithmetic is all about. It's remainder arithmetic. 13 times 16 is 208, and if you really, I'll put plus 0 there just to be arrogant. There's a remainder of 0 here. Okay, and that's this 0 that you see right there. Okay, same thing right here, 6 times 13 plus 0. So y'all, that does it, that verifies it. These are the solutions. And again, I do want to point out that you could have just marched through all, you could have tried 0 here, 1, 2, 3, and gone that path. And it maybe probably is about the same time. But if the moduli get a little bit bigger, if get up in the, say, high double digits, this way is to be preferred because it's generally going to be a little bit easier to interpret the square root of 129, whatever modulo you're dealing with. Okay, thanks.